One of the VLANs that's a little more unique is our voice VLAN. Voice traffic is a little more susceptible to delays, and there are some issues that happens when there's some latency that works into your voice traffic. And so what we like to do is we like to separate that out onto a separate network, a separate subnet, a separate VLAN, so that way we can prioritize the traffic that's within that VLAN. And so let's talk about, in this video, let's talk about those voice VLANs and how we set up those voice VLANs. In this video, we're going to start out by talking about the differences between the data traffic and the voice traffic. Then we're going to get into quality of service and cost of service, and what the difference is between quality service and cost of service, and how it applies to voice VLANs. Then we're going to get into your phone, because your phone actually acts as a switch. And so let's get into talking about the phone and how a phone is set up. When you're on your computer, typically you have a lot of TCP and UDP traffic that's happening. So the TCP is that traffic that creates and establishes a connection, and if something goes missing, then it goes and retrieves that information again. And so it has those built-in error corrections, acknowledgements, all of that fun stuff. Where the UDP is more designed for that faster connection where it just needs to send data, but it doesn't necessarily need the guarantee that TCP has with it. And so your computer will have both of those, but a lot of your traffic is that TCP traffic. You pull up a web browser and it's making connections via TCP. And you want to make sure you get the full web page, and so it's going to download the full web page, and that's using TCP to do that. For that reason, a lot of the traffic that's coming from your computer doesn't have the latency problems with it. Like if things didn't arrive in a timely manner, then it'll eventually get there and you'll get the full web page. Voice traffic is a little different. Now, quite typically, we do a lot of voice conferencing and a lot of things on our computer nowadays, but on a phone, it's definitely all voice traffic that we have on our phones when we're making connections with our phones. And so it primarily uses UDP. Your voice traffic, there is some connection things that may use a little bit of TCP to establish some connections, but then the main data that's going back and forth on your phone lines is UDP. And we want the quality of that phone call to be very high. And so we need to make sure that that voice traffic is being prioritized. In fact, if we find that if there is a latency of more than 150 milliseconds, that voice traffic starts to really degrade. So we set up our networks to prioritize that traffic. So what we can do is we can establish a voice VLAN and then prioritize the traffic that comes across there. But we have to, in order to prioritize this, we have to configure this network-wide. So there's a lot of configurations that happens on these switches to make sure that it can prioritize that voice traffic. So let's get into that data versus voice, what that looks like, and how we would set that up. The term QoS, or quality of service. The term quality of service is just how we prioritize that traffic. We label the traffic as it's being sent across there, and then we prioritize that traffic. Well, that happens, QoS is what we call on that layer 3 level. So QoS is set up on your routers and your layer 3 equipment to prioritize the traffic that comes into it that is labeled with this QoS label. So the cost of service is something similar, but it's on the layer 2. And what we do is we assign a cost to these different traffic, and then that will prioritize the traffic according to that cost. So that is from a layer 2 perspective. So when you hear QoS, think layer 3. When you hear CoS, think of layer 2 with this. We have our voice VLAN. We've already set up the voice VLAN as being 150 on our network here. And so when a phone connects into a switch, then what we want it to do is we want it to be on this VLAN 150, and the cost of that is going to say this is prioritized traffic, and each of the switches is going to handle that traffic before it handles any of the other traffic that comes across it, provided that we've set this up correctly. Now, one of the things that's a little unique about a lot of the phones that are out there, and specifically the Cisco phones, is the Cisco phone actually has a built-in switch to it. So just like you have a switch out here on your network, there is a mini switch that is inside of this phone. There's two ports. One of the ports is connected into that switch. The other port is connected into your laptop or your whatever other device. Now, the reason for this, one of the big reasons for this, is so that way for each of your desks, you only need one port to support that desk. Otherwise, you would need a port for this to plug in to this switch for the phone, and you would need one for the laptop. So you would need double amount of the ports on your switches. You would need double the amount of jacks out there for each of your desks. So for that reason, they have this switch built into the phones. Now, so as part of this, what makes this really interesting is we want these on two different networks. And so we want the demo laptop to be on one of our, well, in this case right here, it's on our management VLAN, but whatever device we have plugged in there, we probably want it on one of these different networks right here. And then we want our phone to be on this voice VLAN. So we want them to be on two different networks. So there's some special configurations that happen with this. What we do is we configure the port to be an access port and to be part of, in this case, VLAN 10, so it can support this computer. But we give it a little extra configuration and say, but we will accept some tag traffic from this phone. So it's kind of a pseudo access port and trunk line. And then this phone will communicate using Cisco Discovery Protocol, will communicate with this switch right here to configure this little pseudo access / trunk port, so that way it can have this phone on VLAN 150 and this computer on VLAN 10. So it's a unique configuration that we have set up just for when you have this scenario right here. And Cisco equipment is all set up, so as long as the Cisco is a Cisco switch, and as long as the phone is a Cisco device, then all of this works out well, and you can set up your configuration just like this. So it's pretty cool stuff, and yeah, it's pretty fascinating how it works, and then it prioritizes that VLAN 150 traffic. So what we talked about is the data versus voice and how we want to prioritize voice. The way we do that on a layer 3 is through that quality of service, versus on a layer 2 is cost of service. And then we finally wrapped it up about some of the differences with the phone, how the phone works. It works as this mini switch, and it sets up this pseudo / access port, but it does have some trunk traffic that gets tunneled to that port onto that switch. So there's a little different configurations that happens with that when we're setting up voice traffic on our network.